Today is our second class on factoring trinomials. Today we're going to learn how to factor trinomials of the form ax squared plus bx plus c, where a, b, and c are all integers. So here's how we're going to write that. So this is just like before, Z is the symbol for integers. We'll look at that more in the next few units. So A, B, and C are just nice numbers, but today A will not equal 1. A can be any number other than 1. So again, what I want you to remember is, as with factoring trinomials, with 1 as the leading coefficient, we get a trinomial of this sort today by multiplying a binomial times a binomial. So again, what I suggest is you go back and look at your notes at binomial expansion, and you will see some of the answers that we're going to start with today, so when we unmultiply. So here's a quick little example of multiplying two binomials, and we're going to end up with a trinomial with a leading coefficient other than 1. Going to go through our area model first. 2x squared plus 3x minus 8x minus 12, and when we combine like terms again, we set it up the same way. Our like terms are in the same spot, our x squared term is in the same spot, and our constants in the same spot, and we would collect like terms. I'll do that on the right when we do it algebraically. Okay, algebraically then, we're going to go fishing. So remember the word FOIL. We're going to multiply 2x times x, and that's 2x squared. We're going to multiply the outside terms, 2x times negative 4, and that's equal to negative 8x. We're going to multiply 3 times x, and that's 3x. And we're going to multiply the last terms of our binomial, 3 times negative 4, which is negative 12. And then we're going to collect our like terms, and our final answer is going to be 2x squared minus 5x minus 12. So again, when you multiply a binomial times a binomial, you get 4 terms initially, and being a good student, you collect like terms, and you get a trinomial in this case. Okay, that turns out to be, again, the problem, just like last day. So notice that we initially get 4 terms, which we reduce to 3 terms by adding the like terms. When we unexpand, we have to get back to 4 terms. We still need to break apart the middle term. So just as we did with a trinomial with a leading coefficient of 1, we have to get back that middle term. And we're going to factor trinomials with a leading coefficient other than 1 in almost the same way. So in almost the same way as last day. So again, I've been saying this in class. I don't consider these polynomials to be very different as last day. The only difference with today is we have this leading term here. It has to do something. So again, we're going to play that game. What are the factors of something that add up to something? But in this case, given that we have a leading coefficient other than 1, we're going to have to do it in a way that that makes it work. So if you notice the example that we're going to do right here, I'm going to do it algebraic, or I'm going to do it pictorially first. And again, I kind of know something. I know how I should break this up. And how I'm going to break it up is I'm going to break it up this way. So again, you might wonder right now, well, how did he actually break it up that way? But I want to do it, I want to just show it to you first, and maybe as we go along, you've already figured out how to break apart negative 5x into these two pieces. So let me go through my pictorial logic, and then we'll go through the algebraic logic, and then maybe we'll notice, well, how do we decompose that middle term? One of the things I want you to notice right now is there are factors of negative 6 that add up to negative 5. And the factors of -6 that add up to -5 are +1 and -6. But notice that I did not enter +1x and -6x. I in fact entered this. So let's go through and have a look at this. Okay, same logic. If this is an x squared term, I have to have an x by x. And now all I want to decide is what has to go where. Okay, so what has to go where? Well, if you look at this, I can break 4 down into 1 times 4 or 2 times 2. Now, I hope you see that it can't be 2 times 2. 2 goes into -8. So if I did put the 2 and the 2 here, then this would work. But this would not work. 2 does not go into 3 evenly. So it's not the 2 and the 2, it has to be the 1 and the 4. And I hope we see that the 4 has to go there. So if the 4 goes there, 4 times what is -8? Well, 4 times -2, and x times 1 is x, so we can just leave it. We'll go do the bottom left one. X times what is 3x? Well, it's x times 3, and just like we did before, we're going to go and look at this last little box, and we're going to make sure that it works, and in this case it does. And now I know I have the right answer. If I were going to do it algebraically, I would do it the exact same way. I would start off with my trinomial. I would break apart my middle terms. So let me just write these in blue. I break apart my middle term into 2 pieces, and in this case, the 2 pieces are -8 and +3, and then I would go ahead and I would do my 2 by 2 grouping, and I would factor out a 4x, and I'd be left with x minus 2, and I'd factor out a 3, and I'd be left with x minus 2, and I've generated my common factor exactly as we've done it all along. There is absolutely no difference, and there's my answer, and it matches the picture. Okay, so now what I want you to realize is I have done the exact same thing. But the only thing we really haven't talked about is how to get these. As I said, there are factors of 6 that add up to -5, but they are not the correct ones. So here's our new little wrinkle. So our new little wrinkle, our new trick. So last day I called it a trick. So last day we looked for what 2 numbers multiply to the last one and add to the middle one. That worked great when there was a 1 in front of the x squared. Here's our new trick. What 2 numbers, what number pair multiply to A times C and add to B? So let me highlight that on the original question. Remember ax squared plus bx plus c? Here is our A and C, and here is our B. So in this example, when we do our little wrinkle of how do I decompose the middle, what I want to do is, in this example, 4 times -6 is -24. I want to know which factor pair of -24, well, what are they? They're -1 and 24, 2 and -12, 3 and -8, 4 and -6, 6 and -4. I'll keep writing them. 8 and -3, 12 and -2, and 24 and -1. Now that looks like a lot of work, but of course we know we can stop when we hit the right one. So our new little trick in doing these kind of trinomials is not the factors of the last, but the factors of the first times the last. All that does is, it is a way to decompose the middle term, so we can go ahead and do exactly the same as we did algebraically. Okay, so again, summarize that. Here it is right here. Our new trick is to decompose the middle. We cannot look at just the first factors of the last term, then add to the middle. We must look at, just to summarize what I just said, we must look at the factors of the first coefficient times the last number, or the constant, and then from that, we must look at the factors of the first coefficient times the last coefficient that add to the middle. Add to the middle coefficient. So that's what we've summarized above in my little trick. Again, this is what you have to do. It beats the guessing and checking. So let's have a look at a couple of examples and do it both algebraically and pictorially. And again, you do it however you want. If I were going to do this pictorially, the first thing I could do is I want to be consistent, as I've done before. And what I want to know is, what are the factors of 6 times 6, 36? What are the factors of 36 that add up to negative 13? We have 1 and 36, we have 2 and 18, we have 3 and 12, we have 4 and 9. Now I'm going to stop there because 4 and 9 adds up to 13. So negative 4 and negative 9 multiply to positive 36 and they add to negative 13. And this is the pair I want. So I'm going to insert those. It doesn't matter where you put them as long as we are consistent diagonally. And now pictorially, I'm going to go ahead and figure out the dimensions. Well, again, the factors have to be, this one has to be x and x. And now we just have to go, is it 1 and 6 or 2 and 3? I hope you see it's going to be a 2 because 2 goes into negative 4 and 3 goes into negative 9. And now we're just going to fill out the other 2 and check our answer. 2 times negative 2 is equal to negative 4, and x times 1 is equal to x, and 3 times negative 3 is equal to negative 9, and so on, and negative 2 times negative 3 is equal to 6, so I know I factored this right. If you're going to do it algebraically, now remember, I'm stopping here because I don't want to write out a set of brackets twice, but that's not the answer. You have to write these two dimensions as a product of brackets. Okay, so let's look at it algebraically for those of you who like to do it this way. The only difference is we are going to break apart the middle in exactly the same way we've done over there, and we get negative 4x minus 9x plus 6. And we're going to make our two groups of 2. And we're going to factor out the greatest common factor. So 2 and x go into both those terms, and I'm left with 3x minus 2. Over here, again, this is where the algebra is tricky. 3 goes into both of those, but I want a 3x minus 2, so the factor I actually want to take out is a negative. So pictorially, we never worried about that. Algebraically, you do. Either way, you get this. Again, algebraically, beware of negatives. And again, what you should always do is multiply that out and check your answer. Okay, one last one. Factor 9x squared minus 12x minus 4 completely. And again, everything's completely. So we're going to have 9x squared and 4 there, and we're going to break apart the middle term by multiplying 9 times 4, which is 36. What are the factors of 36 that add up to negative 12? Well, 1 and 36, 2 and 18, 3 and 12, 3 and 12, 4 and 9, 6 and 6. So 6 and 6 add up to 12. So this is the one we want. We want the negative 6 times negative 6. And what we can do then is we can break apart negative 12x into its two pieces. And now we can find our outside dimensions. Well, again, this has to be x and this has to be x. And now we have to ask ourselves, is it 1 times 9 or is it 3 times 3? And 9 doesn't go into negative 6, but 3 does. So it's going to be 3 times 3. Up here we have negative 2. Down here we have negative 2. And we do our check. And negative 2 times negative 2 is in fact positive 4. So we have our answer. If we did it algebraically, we'd do it the exact same way. We'd break apart the middle term exactly as I've done in the middle. So this middle column of breaking 36 is common to both methods, whichever one you choose. The only difference is this is algebraic, and I think it's a bit trickier, but again, ultimately I want you to be able to do that. Right here we have a common factor of 2, and I want my last term to be negative and the first term to be positive, so we have to take out a negative in this case, and we end up with 3x minus 2 times 3x minus 2. And another way of writing that is 3x minus 2 squared. So there's factoring a trinomial with a leading coefficient that is not 1. And what I want you to do for next class, which I will collect. So at the beginning of class, you're going to hand me a piece of paper, and it's going to have this on. Summarize how to factor a trinomial of the form ax squared plus bx plus c, where a does not equal 1. And basically, I want you to write me what you would write down on that little summary sheet that I gave you. You're going to put your name on it, and you're going to hand it in. And it might be useful to use an example as you explain.